Good evening, all. I would like to extend my warm welcome to everyone, including our honorable speakers, Ajay Poojary, Wrintegn India Private Limited, and Dr. Ashalatha from College of Engineering, Trivandrum, to the fifth day of this session. Today's session is scheduled as from 7 to 7:50. Mr. Ajay Poojary will be sharing his experience on recycled pavements and foam bitumen technology. 7:50 to 8 is reserved for discussion related to the topic. From 8 to 8:50, Dr. Ashalatha will be sharing her experiences in CET, which will again be followed by a 10 minutes discussion session. 9 to 9:30 is scheduled for detailed discussions. Now, I would like to welcome our first speaker, Ajay Poojary from Wrintegn India Private Limited. He did his BTech in Civil Engineering from NMAM Institute of Technology, Karnataka, and Masters in Transportation Engineering from NIT Surathkal, Karnataka. He has been working as the Assistant Manager in Product Management at Wrintegn India Private Limited for 4.6 years. I welcome Mr. Poojary to share his experiences on recycled pavements and foam bitumen technology with great honor.
Yeah, thank you. Good evening, everyone. So myself Ajay. So I'll be sharing you my experience on recycled payments and all the job site scenarios where we have done cold in place recycling.
Ajay, can you please switch on your video? It's off right now.
Yeah.
If possible.
Is my presentation visible, ma'am?
Yeah, presentation is visible.
Yes. Yeah, so there's some issue with my video. Is it in full screen mode presentation?
Yes.
Yeah. Can I start?
Yeah, sure.
Yeah.
Video is off if you wish.
Yeah. No, actually I'm facing some difficulties.
Okay, fine. Okay, we'll proceed.
I'll check once again, just. No, ma'am.
Okay,
I'll start. Yeah.
Okay.
So once again, good evening, everyone. So today's topic is on recycle payments using foam bitumen technologies. So before I go into the topic, so just I will go give a brief description of our company. So it's a German company, Wrintegn. So we have our Indian headquarters at Pune. So we are market leaders in road construction as well as rehabilitation equipments. So in India, we have been operational from 25 plus years, and we have 5 strong brands: Wrintegn, Fogley, Ham, and Kleeman. Wrintegn, we have different machines from ranging from cold milling machines to recyclers. So this is the same machine that is used for CIPR, the cold in place recycling. And next we have Fogley. So these are the asphalt pavers, which is used for paving the asphalt surface. Ham, we have variety of compactors, and Clayman, we have jaw screen and crushers. And next is bending over, that is not right now in India. So coming back to our topic, so as you can see from the pictures, these are the various defects in road, like rutting, bleeding, maybe pothole cracking, maybe to some extent the full depth cracks. So there are various reasons that attribute to a failure of a wearing course. So it might be due to improper mix design, or maybe due to improper gradation of aggregates, or maybe your inadequate binder content, or your poor compaction quality, or maybe due to inadequate your quality control procedures. So all these various reasons attribute to a failure of a wearing course. So coming to payment maintenance cycle. So if you do resurfacing in timely manner, so it increases the road lifetime. So you can increase the design life of a pavement, but your deformation and fatigue cracking, so it requires your structural rehabilitation of your asphalt pavement. So coming to pavement rehabilitation, so depending on the pavement conditions, we go for full depth asphalt pavement rehabilitation for the upper layers of the asphalt layer. So one option you have is mill the existing damaged asphalt layer using a milling machine, and then you can reuse it 30% back into the hot mix. So the code allows 30% reuse in the DBM layers, but the question arises what you will do with the remaining 70%. Whether you're gonna dump it or dispose it in the nearby areas, again it causes environmental problems. So there is a question arising, why can't we use 100% of RAP back into the system? Coming to resource optimization, as I said, one option of pavement rehabilitation is mill and fill. Mill the existing asphalt layer, uh, take it back to the hot mix plant, and use it 30% back into the system. But there is one more option where you can get 100% RAP back into the system. That is called CIPR, cold in place recycling. So this ensures 100% reuse of RAP back into the system. So we do it in situ way. It eliminates any heating of the existing aggregates, and we require only 2.2% of bitumen as binder and 1% cement as filler. So what is cold recycling? So CIPR, as the name called, so it's a method of removing and reusing the existing asphalt surface. So it involves grinding of the existing top asphalt layer, and we mix it along with the pre-spread cement and bitumen as foam, and we place it back to the surface. So here the existing pavement is not heated at all. Only the bitumen is heated at the temperature of 160 to 180 degrees Celsius. It depends on our job mix formula and as well as a design criteria. Here foam bitumen or emulsion is used to bind the cold aggregates. In emulsion, as you know, water makes up to 30%. So 1.3 times the amount of emulsion is required to add the same amount of bitumen. Suppose if we go for emulsion, it just creates patches in the surface of the aggregates. But whereas in case of foam bitumen, we add 2.2 to 2.4% of VG30 bitumen. So it covers the entire surface area of aggregates. So hence we get more bond and hence better riding quality. So for the code for the recycling of pavements is IRC 37, 2012 and 2018, as well as IRC 120. So in situ recycling, 100% RAP is used back into the system. We add 10 to 15% of fresh aggregate as per the missing gradation, 1% cement as filler. The modulus, when we check in the lab, we get close to 1400 MPa, but the code specifies a modulus of 800 MPa for the recycled mixes. So CIPR is executed mostly in situ way. So we can roughly do about 1 lane kilometer per day. So hence we get reduced logistics resulting in economical and greener payments. So next is a short video here. You can observe the CIPR process.
Is there any audio for this video?
Yeah, I think audio was
Not able
playing.
to. No,
Okay.
they're not
Sorry.
able.
Okay. Next coming slides, you have the pictures. I will explain it.
Maybe you can replay it.
Is audio coming now?
No.
Okay. Sorry. I will explain in the coming slides. It's
Okay.
okay. Yeah. This is the foam bitumen concept. So on the left hand side, you can see this is the nozzle for the hot bitumen. So bitumen will be heated at a temperature of 160 to 180 degrees Celsius. So we generally use VG30 grade. So when hot bitumen, when it comes in contact with water, is the water line. So when it comes in contact with water as well as compressed air, so it expands 18 to 20 times its original volume. So it creates foaming of bitumen. So this foam bitumen, it covers the entire surface area of aggregate. So all this process happens inside the mixing chamber of the machine. So right hand side, you can see this is the mixing chamber. This is inside the machine. We have the water line as well as the bitumen line, which are attached to the machine. So this drum, so this drum, it granulates the existing asphalt layer and mixes the pre-spread cement and along with the foam bitumen. So we get a BSM layer. So that is called the bitumen stabilized material. So all this process happens inside the machine itself. So some more pictures of the drum of the machine. So you can see there are a total of 16 nozzles. The blue line is the water line and the brown line is the bitumen line. So it mixes water, foam as well as the existing pavement. These are some of the job site pictures. This was from one of the site from Rajasthan. So I'll take you through that. So coming to rehabilitation options, we have different kinds of solutions. On the left hand side, you can see the complete asphalt layer is damaged in the top. So one option, you can go for total reconstruction, but it is, as you know, it's an expensive one. It leads to long construction time as well as traffic will be a huge issue there. Second option, you can go for an overlay, quick overlay, but the problem is it's not a permanent solution. So it's just a temporary relief layer. So these cracks will be propagating in top layer in due amount of time. The third option is mill and fill. We eliminate the existing cracks we mill it using a milling machine, and then we can reuse the wrap back into DBM layer. So here the code allows 30% of wrap in DBM. This one more options. And the last one is CIPR. So depending upon the project economics, how much quantum of work you have, you can always choose either of mill and fill or CIPR. So here you have the option of using 100%, getting wrap 100% back into the system. So you get a faster construction of 1 lane kilometer per day. And then after the BSM layer, we lay a BC layer on the top of it. So these are some of the job site reports. So I will take you some of the projects where we have executed the CIPR in India. So from last 8 years, we have roughly done 4 million square meters of recycling of asphalt layer. So depending on different traffics from ranging from 10 MSA to 180 MSA, we have executed our works, and the performance is par with any conventional methods. So this is the first recycling project that was done in India. There's NH5, Chennai Tada. So it connects Chennai to Nellore. So project was executed under the guidance of Professor A.V. Raghavan from IIT Madras. The project was executed by L&T. So here we recycled the asphalt layer up to a depth of 190 to 200 mm in situ. So we required 2.2% of bitumen as binder here, and we added 1% of 15% of crusher dust and 1% of cement as filler. And the final layer was laid by 50 mm BC layer. And this was designed for traffic of 87 MSA. some job site pictures. So this was the condition of the road before recycling. So as I said, you have two options. You can decide based on the project economics. So option one is mill and fill, mill the existing damaged asphalt layer and use 30% back in DBM. And second is the BSM layer, where you completely reuse the complete damaged asphalt layer back into the system, and we seal it with the 50 mm BC layer. So each of these two options, either mill and fill or else CIPR, they have the same structural capacity. So first option is mill and fill, and the second option is CIPR. So this was a mixed design that we did in IIT Madras under the guidance of Professor A. Veera Raghavan. So here the samples corrected, we checked the gradation and we put inside a Pavement. So this is a Wrintegn foam lab. We check it for finding the optimum foam, water content as well as temperature to find the optimum foam design. So optimum foaming process is tested to find need to find out the optimum percentage of water as well as temperature. So to gain the maximum expansion ratio as well as half-life. So minimum criteria as per the codes is we need to get a half-life of greater than 6 seconds and expansion ratio greater than 8 times. So this should be satisfied as per the TG2 guidelines 2009. So then we cast molds, then we check for ITS, indirect tensile strength. So this is done to check the susceptibility of the binder coating to moisture damage. So as per IRC 37, so minimum criteria for ITS values are, we should get a ITS dry value of 225 kilopascal and ITS wet of 100 kilopascal. So these are some of the values from the mixed design. So we reuse back 200 mm of existing asphalt layer with the addition of 10 to 15% of fresh aggregates, 2.2% of bitumen and 1% cement as filler. So these are some of the job site pictures. So initially here we on top of the damaged layer we spread the crusher dust and then we grade it to the profile. Then the second step is this is the cement spreader. So it's a microprocessor controlled system where depending upon the depth as well as density, this spreads the cement. So it is an automatic controlled machine. And next is the Wrintegn recycler. So it granulates the existing asphalt layer along with the addition of bitumen and water. So bitumen and water tanker will be coupled front of the machine. So this machine pushes the water and bitumen tanker. So bitumen will be preheated and stored in the truck. So at the temperature of 160 to 180 degrees Celsius as per the design. So after this process, we get the roller. It's a 20-ton roller to get better compaction results. And then we grade it as per the to get the profile. And then we have the single drum roller and the pneumatic tire roller to follow. So this is the procedure, how we execute it inside. Some more pictures. You can see the bitumen tanker and a water tanker coupled to the machine. So this was the asphalt layer. So it was intact till 2020 and we just needed some minor rehabilitation to follow after this process. So this road was completely intact. So coming to cost economics, as I said, depending on the project conditions, we can either choose either of mill and fill or CIPR. So here, by using mill and replace option, we could get a rough cost of 314 lakhs per kilometer. But if you go with this CIPR process, we got a cost analysis of 204 lakhs per kilometers. So there was huge amount of initial cost savings. So we were able to bring down 35% of cost savings by using CIPR technology. Coming to fresh aggregates requirement, if we had gone with mill and fill, we had to require roughly 8,000 tons per kilometers of aggregates. but by CIPR, we required roughly 3,000 tons per kilometers. So roughly again 65% savings in terms of fresh aggregates requirement. In terms of fresh bitumen requirement, we could save roughly 25% in this project. Coming to next project, this was from NH66. The contractor was EKK. So it was from LAP to Ambalpooza in Kerala. This was, I think, executed during 2020 under the guidance of contractor EKK. So this was a MORTH project. Design was 60 MSA. So this was the existing condition of the road. Again, you have two options, either to go for mill and fill or BSM. So here we recycled the top 150 mm damaged asphalt layer and we sealed it off with a 50 mm BC layer in the top. So again, this project involved addition of 15% of fresh aggregates into the system, and we had cement 1% as filler, and bitumen requirement was 2.2%. So the complete damaged layer was recycled in situ, and then we sealed it with a BC layer on the top. So as I said, it's a quick process. We could complete 1 lane kilometers per day. So the coming to construction costs, so roughly it will be including the machinery, it is roughly around 5,000 cubic meter rupees per cubic meter. So some pictures of site execution. So you can see on the right hand side we have the traffic going, left hand side we are executing the project. So this is the pre-spread of aggregates. And second, you can see we are spreading the cement as per the design. And then this machine comes, which we recycled. We recycled the existing pavement with the addition of your cement as well as bitumen. Short video. So this machine will be in the coming project in Trivandrum. This machine will be running. So it's for one more technology called FDR, full depth reclamation. So we'll be starting this in the next week. So if you have to visit any job site, I think you can plan for this stretch. So this is a recycled surface after this CIPR. As I said, this is the process. We pre-spread the cement, then we recycled it with the machine, and then the heavy duty compaction, and then we grade it to the profile, followed by the compaction process. So in this project, we could come down on 60% savings in terms of aggregates and also in terms of cost. This is one more project, NH62, Biawar Pali Pindwada. This was executed by L&T. So this is some of the field investigations which was done. So we dug up the test pit observation. A total of 6 pits were dug, measuring in size of 1.2 meters. So it was dug up to the subgrade level at 6 different locations of this job site. And then next, coating of bitumen mix was done to evaluate the depth of the crack up to which this asphalt layer is damaged. Then we collected this milled material for evaluation of wrap mix design in the laboratory. And various laboratory tests were done, and then the project was executed. There are two options. So here we recycled 130 mm in situ with addition of 10% of fresh aggregates, and we then sealed it with the 50 mm BC. So these are some of the IIT values for fatigue and Wrintegn criteria. So these are the job site pictures. So here you can see the bitumen tanker and a water tanker, which is coupled to the machine. So these are the execution process. As you can observe from the pictures, first we pre-spread the aggregates as per the missing gradation. Then we spread the cement using the microprocessor controlled cement spreader. Then we pulverize the existing damaged asphalt layer with the addition of the bitumen as foam and water as per the mixed design. Then we grade it and compact as per the design. And then top we cover it with the asphalt layer. So these are some job site procedures. So the existing asphalt layer is we spread aggregates as per the missing gradation, and we grade it with a grader. These are the fresh aggregates being laid, and then this is the cement spreader. We spread it using this as per the design. And here we recycled roughly 130 mm. And the next is we do a heavy duty compaction. This grading, we grade it to the profile and we get a recycled surface. Then we lay a tack coat and a BC top of the BSM. So we need to cure the BSM layer for 48 to 72 hours before laying of BC layer. So these are some of the job site pictures. There's one more site in NH2 Varanasi. Here we recycled roughly around 130 mm of the existing asphalt layer. So coming to market acceptance in India, so we have roughly done around 40 million square meters using these technologies, and another 400 kilometers we have executed in plant way. These are the summaries from the various projects we could save on aggregates, we could have saved in bitumen and as well as emission. These are some of the pictures from the site execution. So we check the bitumen temperature, and also we check the expansion ratio and half-life. We check the bitumen which is being injected to the machine, and also we check the density in the field. And after the existing layer is relayed, we take the samples for evaluation in the lab. So coming to the code recycling summary, as I said, it depends on project to project. So the average working depth in India is roughly 100 to 180 mm. So we recycle DBM and BC together. So 100% your wrap is reused in the system in situ way. So only we require an addition of 2.2% of bitumen as binder, VG30, and 10 to 15% of fresh aggregate as per the design. So here there is no any heating of fresh aggregates. The approximate cost for this is, including the machinery, is 5,000 rupees per cubic meter. So it's a faster construction, you get savings in emission, and roughly you can complete 1 lane kilometer per day. So this is the Wrintegn foam lab. So it's been used in 5 institutes from IIT Madras to CRRI Delhi to IIT Kharagpur. Also we have in IIT Roorkee as well as Mumbai. So here we do the design using this laboratory. So thank you. That's it from me.
Now the floor is open for queries. Participants can unmute and ask the questions or post the questions in the chat box. So the first question is, what percentage of water should we add in CIPR? Is there any range, or it is depend on the sign?
Again, we have to check it in the laboratory. So while doing the design, it depends on the site conditions. And as I said, in the laboratory, we have to check for different water content. So we change the dosage from 4 to 6% and check for the best foaming content. So we need to check for foaming temperature as well as foaming water content. So we cast different molds and check it, and then we do that ITS dry and wet cycles. So there we will get the exact values.
Participants are requested to ask the queries.
I have one query. If
Yeah.
suppose filler content is more in that milling process, how that can be tackled? Because we are not removing any material out of it. So what is the how is it tackled?
If the filler is more in the existing asphalt layer.
No, in the milling process.
Okay.
If
That's
suppose
what. While spreading or in the existing layer.
the milled material already existing after milling.
That's why initially when we start the project, we have to take the what you say codes, and we have to check the gradation analysis. Suppose your big aggregates are coming more, we need to add fillers. Suppose if fillers are more, then we have to change the design accordingly. So we have to change the dosages of cement accordingly and work out the mixed design.
Yes, but still, if the filler content is like is more,
Yeah.
if we could more than the what is required.
So the one more option comes, you can if that filler is small, you can mill it off and take the layer back, and then reuse the what you say. Suppose you can mill 20 to 30 mm, whatever is there, and then we can use a cold recycler machine.
Okay.
Yeah.
Thank you, sir. The next question is from M. Surendranath. Is the amount of fresh binder and cement constant as 2.2% and 1%, or does it depend on the mix design? In all the projects, it was 2.2 and 1 only.
Yeah, it depends on the mix design. So as I said, bitumen ranges from 2.2 to 2.4%. So the various projects which we have executed, so roughly it was lying in this range only, 2.2 to 2.4%. And cement, usually we add just 1% only as filler. So all depends on the mix design, but the basic range is exactly the same, 2.2 to 2.4%.
So what is the present condition of those executed projects?
As I said, Chennai Tata was the first project. So it was intact till 8 years. And then we had just a minor distresses. Then we milled it and laid asphalt layer in the top. So it's running perfectly well in the various projects we have executed using this technology. So again, it depends on the project economics. Suppose if you have just a 10 or 15 kilometers project, so I think this project, this way is not feasible. So if you have big quantum of works, roughly 25 to 30 kilometers, so you can work out, definitely you can work out using this technology.
So the next question is, have you considered the maintenance cost in the savings that you have claimed?
No, we have not involved the maintenance cost. So just initial cost we have considered, we're calculating.
Participants can raise queries if any. Sir,
Sir,
can you share the details of milling blades?
Yeah, definitely. So this is made from heavy duty material milling drum. It's from HT22 grade tungsten carbide. So we have cutting tools inside the milling drum. So it's used for high wear and tough roads. So it roughly we have 160 numbers of cutting tools inside the milling drum, and every 10 to 15 meter we need to replace it uh, accordingly. So roughly we take an average life of 100 square meter per each cutting tools. So depending on the road condition, how tough the road is, we change the cutting tools. So it's what you say, all these costings are included in the cost which I had said, roughly around 5,000 rupees per cubic meter. So roughly the cost by adopting this technology is 4,500 to 5,000 rupees per cubic meter.
Thank you, sir.
Yeah.
The question is from M. Surendranath. May I know the location of your upcoming project? What is the status of your upcoming project?
The upcoming project we are executing in Kerala, but it is not by CIPR. It's a FDR technology, full depth reclamation. So it will be running in Trivandrum in the coming week. It's under KRFP projects. So we have two packages there. So I think roughly 30 kilometers from Trivandrum. So it will be starting from next week. So I think you can contact me if you want to visit the sites. My contact number is there. So definitely we can help you in the site.
Participants can unmute and raise the queries. Hoping there are no more queries, I request Mr. Ayanath, Assistant Professor in Civil Engineering Department from Annapurna Engineering College, Tamil Nadu, to thank the speaker.
Good evening to everyone. Today I feel incredible honor and privileged to have been allowed to extend a vote of thanks on this auspicious occasion. I extend my gratitude to our honorable chief guest, Mr. Ajay P. Poojaria, product manager, Wrintegn India Private Limited. He, to take out time from his busy schedule to grace this event. He's sharing the knowledge on recycled pavement and foam technology for this session. So it's very useful for and wonderful session for this year today session, sir. It's we get more knowledge about the pavement, recycled pavement and foam fitness technologies. And you show the more pictures for the your site visibility. So it's very essence, and we get more knowledge about that pavement design, sir. And I must thank the organizing teams and volunteers for working hard for the past few days. And my special thanks to the coordinator, ma'am, Dusra, ma'am. It's very successful event for this occasion, sir. Thank you, ma'am.
Thank you, sir. I request you to join for the detailed session scheduled from 9 to 9:30 p.m. And all the participants are requested to fill the feedback and the form shared in the chat box, and we'll start the next session by 8 p.m. All the participants are requested to fill the feedback form for the session, and the second form is the mixed design awareness questionnaire, which will help to plan the offline session mixed design classes. Please fill the forms. Participants are requested to fill the two forms shared in the chat box, and we'll start the next session at sharp 8 p.m. You can keep asking the queries, which will be addressed over the chat. Hope everyone filled the forms. So I would like to welcome Dr. Ashalatha R from College of Engineering, Trivandrum. She did her bachelor's in civil engineering and master's in traffic and transportation engineering from CET and secured her PhD from IIT Roorkee. She served as a scientist in Central Road Research Institute, New Delhi, and has about 20 years of experience in teaching and research. She served as head of Department of Civil Engineering at Government College of Engineering, Kannur, and has been serving as a research coordinator of Transportation Engineering Center at CET. She has many publications in national and international journals and conferences. Her papers are backed IRC Commendation Certificate and Best Paper Award at World Conference on Transport Research. She also bagged the Best Researcher Award from CET. Her research projects have been funded by AICTE, TRC, KSCSTE, and is also the reviewer of journals like ASCE, Journal of Traffic and Transportation Engineering, Journal of the Institution of Engineers, etc. She is currently working as a professor in civil engineering at CET and is also the center coordinator for FDP. With great respect and honor, I invite Dr. Ashalatha R to share her experiences at CET.
Thank you, Serena, for that nice introduction. Am I audible? Hello.
Yes, ma'am, you are.
Okay. Okay. So good evening, participants. It is indeed a good opportunity to interact with you and to discuss what we have done in CET in this particular topic. Basically, I did my PhD in traffic engineering, and I have got interest. I have done few work in materials too. And this work on reclaimed asphalt pavement I have taken on the advice of Professor Pandey, one of the most eminent professors in IIT Kharagpur. Once he had visited our institute. At that time, long by it was in 2012, we had conducted FDP. So sir had asked me that you should start doing work on RAP. So actually, I got inspiration from him and I guided to MTech thesis in 2013 and 2014. But due to various issues, we couldn't continue those works. But what I thought is like myself and Tushar was discussing with Murli sir also. So we thought that whatever work we have done in CET, it is better we project it in such an FDP. And maybe, and I understand that you already heard a lot of lectures by eminent personalities who are like updated in all the aspects, all the revisions and guidelines. And this might look little bit odd because it's a work done in 2013-14. So we have referred to old codes and all. So I would like, in a lighter vein, I would like to see it's more of a historical importance. But as CET is concerned, we would also like to place ourselves in this group that we also have done some work. And of course, with Tushara getting her degree, we are sure that we'll be going with more vigor and vitality in one of the most emerging areas of pavement engineering. So though I have got number of slides, I was just pulling in the slides which two of my tech students have done. So you might not feel it in a very sequential manner, and please pardon me. In a nutshell, I would tell you what this entire presentation is all about. So we wanted to know how to design reclaimed asphalt pavement mix. And that was the first aspect we tried with an MTech student. And we used simple direct methods already existing in literature. And we collected RAP from 3 locations in Trivandrum. And so that means we made 2 samples. And then we conducted various performance tests we followed, which is what is the percentage of RAP to be added. And then we conducted various performance tests to see how well it performs compared to the virgin mixes. And later on, we continued this work with using Sassobit, adding Sassobit, and to see what improvement, or does it make any improvement to the RAP mix. So that is in a nutshell all about my presentation. Okay, I think with this introduction, I'll just quickly go on to my presentation. I hope it is in slideshow mode. Hello?
No, ma'am, it is not.
It is not. Okay. Now it's okay.
Yes, ma'am. Okay.
Okay. Okay. So just few introduction. Already you heard all of most of this and you're familiar. But to start with, we know that recycling hot mix asphalt material that results in reusable material of aggregates and asphalt binder, very important need for a country like India, where there is an infrastructural boom that is coming, quarries are depleting. So we have to find out some way out so that we use the already available or reclaimed material to its maximum. Okay, and recycling of this asphalt pavement is a valuable approach, both from the technical side, economical side, and environmental reasons. And it is, of course, it is getting more prominence with the contribution of the experts in this field and with the industry. It has become more important one, but I think in outside countries, it has already extensively used. And we know that because of the various ecological and economic advantages which contribute to the enhancement of the recycling process. These are the ones, as I said earlier, to conserve the aggregates and binder to reduce the cost of transportation. We can preserve the existing pavement geometries, conservation of energy, labor, and decrease in the pavement thickness or height. Okay, so we know that RAP is actually deteriorated bituminous mix, which contains aged bitumen and aggregate, and its performance as such is poorer when compared to that of the fresh mix. Okay, but we have to use it. How to make it better or almost equal to that of a fresh mix and use it. So bituminous recycling is to gain the properties of the RAP such that it tends to perform as good as fresh mix. Okay, so it involves mixing of the RAP, fresh bitumen, rejuvenators, and new aggregates in suitable proportion. So what is that proportion? That is what we were exploring in our first work. And later on, we tried to use warm mix asphalt additives, because it is known that warm mix asphalt additives, they reduce the temperature of production of mix and stiffness of the aged binder. And warm mix asphalt technologies in practice, like VMA foam, Asphalt, Sasobit, Evotherm. Okay, coming to the need for the study at that time, that was way, as I said earlier, way back in 2013, the recycling, we know, like we are already, we understood the importance of the country switching over to recycle asphalt pavement, and it is something which will happen in the near future. And this use of the recycle asphalt is a technique. As I said, it's a sustainable. It comes under sustainable engineering, and developed countries are already they have moved well ahead in this particular area, and we are only in the initial stage. Of course, now we are improved a lot, and the RAP, which consists of this aged binder with high when we add the WMA additives like Sasobit, we use Sasobit, it generally reduces the viscosity of the asphalt binder. And coming to the objectives, to develop a mixed design procedure for reclaimed asphalt pavement, and to investigate the suitability of using the reclaimed asphalt mixes by conducting the various laboratory experiments, and to compare the variation properties of the recycled mixes with the virgin mixes, and to develop methodology for design of bituminous concrete mix using RAP with Sasobit as additive, and to conduct the various performance tests to evaluate the permanent deformation, moisture susceptibility, and stiffness of the bituminous concrete mix with RAP and Sasobit, to compare the performance bituminous concrete mix with RAP and RAP with Sasobit, and that will be compared with the original bituminous concrete mix. And this was the methodology. So I already said it has two parts. In the first set, we were developing like what is the procedure to be adopted. So for that, we collected RAP from two locations in Trivandrum city, and we characterized the RAP like the binder content determination using centrifugal bitumen extractor, and extraction of the aged bitumen using rotary evaporator, and the sieve analysis was the extract aggregate was done. And also we determined the properties of the aged bitumen, aged aggregates, and the fresh aggregates, because we need some fresh aggregates too, as well as the virgin bitumen. So all those properties were tested, and Marshall mixed design approach to prepare control specimens was adopted, and bituminous concrete mixed with normal aggregate size of 19 mm, that's grade 1, and average pavement thickness of the pavement of 50 mm, that was adopted. And we determined the binder content, and the specimens were prepared. Based on that, we first found out the optimum bitumen content, and we prepared the specimens, and then we conducted the various tests on it. And the recycled mix design process to prepare the mix with RAP. In that case, we found out what is optimum amount of the RAP we have to add in the mix. And that was found, this was the one which we found in the literature at that time. It was found out using the viscosity blending chart, and the recycled mixes were prepared. And we also determined and compared the performance of these mixes. We conducted creep tests, dynamic modulus tests, indirect tensile stiffness modulus tests, indirect tensile strength tests, etc. And of course, these are the, of course, since it's an old work, these are the specifications, or the more specifications at that time, and the standard gradation for bituminous mix. And we used VG10 and VG30. Actually, VG10 was used as a recycling agent, and coarse aggregate, fine aggregate, and mineral filler. And as I said, RAP was collected from two locations. One was of age 3 years old, and the other 5 years. And the RAP which was collected from the first sample, the sample one, that was a bituminous concrete mix, and other was a pre-mixed carpet type. And this is a gradation of the aggregate for bituminous concrete and gradation of the recycled aggregate, the upper limit, lower limit, and what we got for the RAP aggregate. Okay. And rotary asphalt, we use rotary evaporator to determine, that is, we needed to understand the characteristics of the bitumen. So for that, we wanted to extract the bitumen from the RAP, and bitumen recovered from the solvent, which by using this rotary evaporator. So that ensures that there's a minimum change in the bitumen property. So we adopted that. And the bitumen recovered from the solvent by this practice can be tested using the same method as for the original bitumen, and we compare, and the comparison properties can be done. This slide is not more. Okay. Okay. So this is the rotary evaporator. I think already the photographs have been shown by the other speakers. And we actually, for this, we went, my students, and we went to IIT Madras, and we sought their help because our institute was not having such a setup. And then we tested the properties of fresh aggregate and that of the RAP aggregates, and also the properties of the bitumen, the virgin bitumen, that is VG30 we use, and VG10 was used as a recycling agent, and also the aged bitumen extracted from the RAP. So all the various properties of bitumen were also tested, and that is shown here. And also we conducted the Marshall mix design for the virgin mix, and the optimum bitumen content for the virgin mix is obtained at 5.2%. And coming to the recycled mix design. So the basic requirement of the mix design is like the quantity of the old aggregate and new aggregate, we have to adjust it in such a way that the resulting gradation of aggregates, it conforms to our specification. Okay, or the specified gradation. And the quantity of the aged bitumen, the virgin bitumen, and the rejuvenate. In this case, it was VG10 was used as a rejuvenator. And if any we have to adjust in such a way that the resultant viscosity becomes equal to the desirable viscosity at the operating temperature. And the total quantity of the binder should be adjusted in such a way that it satisfies the desired binder quantity of the target mix. Okay. And then the other volumetric and strength parameters of the mix should also be satisfied. And so the basic objective is to know what is the best constituent, or what is the best proportion of the RAP, the virgin binder, and the new aggregate, and to estimate what is optimum RAP content, the best proportion between the aged and the virgin binder, that has to be ascertained first. And the proportion between the aged, the virgin and the aged binder can be estimated by using the viscosity mixing rule. And the percentage of the recycling agent that's required to meet a target viscosity, that is determined. And then we prepare, so that is just to start with, and then we do few trials. That is trial blend, which consists of the recycling agent and the reclaimed RIP binder that is prepared, and the viscosity of this trial blend at 135 degrees centigrade, that is then compared to the with the target viscosity. Okay, if the blend viscosity is not within the limit, then we it's a trial and error process. We keep changing until we get the target viscosity. Okay, so this is the chart which we use, ASTM D4887. So this is, so we'll fix the target viscosity here, and and the point where the line bisects this, you bring it down, project it down, so you'll get the weight to the recycling agent in the binder in percentage. So the present study, we use 135 degree temperature as a reference temperature, and the target viscosity has been chosen as 2183 centipoise for VG30. And the target of the present mix design problem, as I said, is to achieve viscosity of the recycled mix at the reference temperature, which is similar to that of VG30 grade of bitumen by using VG10 grade of bitumen as a recycling agent. And so for this first sample, so this is how we did it. And so from this figure, we got it that 83% by weight of total binder is required to meet the target viscosity for achieving the desired viscosity. And various trial blends of the aged bitumen and the virgin bitumen at different proportions are prepared. And then, so this is the first sample, and this is the trial and error process. And finally, we found that when we have it in the ratio 70:30, that's proportional recycle agent and the wrap binder, it was almost closer to the target viscosity. And the relationship between, okay. So this is showing that plotting the percentage weight of the recycled binder along with the viscosity of the binder at 135. The slide is not moving. Okay. So, so Marshall test is then conducted to estimate the optimum bitumen content by checking the various volumetric and strength parameters with varied binder content. And the binder content is varied while keeping this proportion. This proportion we kept is kept constant. That is a proportion between the aged binder and the virgin binder. And the common zone of the binder content for which all Marshall parameters satisfied is found out, and the binder content within the feasible zone was taken as a design value. So then, for doing the recycle mix design, so we have to find out what is the percentage of the binder present in the wrap, what is the proportion we already obtained, and then we have to also find out what is the percent total binder demand for the recycled mix. So we use this above expression, which is given Asphalt Institute Manual MS30, to find out the quantity of the wrap, percentage of virgin binder, and the percentage of the new aggregate. And so those calculations were done. And then, so these are the calculations that was done for different bitumen content for 0.5, 5, 5.5, and 6. So knowing the gradation of the wrap aggregate, the fresh aggregate is chosen such that the combined gradation satisfies the desired gradation as per more. Okay. So this is how it was done for different proportions. And then Marshall parameters were determined for the recycled mix for different bitumen content, and optimum bitumen content was obtained as 5% for recycled mix, and the corresponding quantity of the wrap was 48%. You can see in throughout our presentation, wrap content, we are getting it on the higher side, especially when you use as a bit. And then the same thing was again repeated on the other sample. The same process was repeated. So we found out the ratio of the recycling agent and the aged binder for the second case, and we found out which is the best proportion for this, which is nearer to the target viscosity. And also then keeping for different binder content and keeping that proportion constant, we found out what is the percentage of virgin bitumen, percentage of the wrap, and the percentage of the new aggregate in the recycled mix. And Marshall specimens parameters were determined for the sample 2 for 3 bitumen content, and optimum bitumen content was determined as 5.2%, and the percentage of wrap was 47.75%, and the percentage contribution of binder from the wrap was 45%. And the next aspect was the sasso bit, what advantage does it offers. So most of you must be knowing what sasso bit is. It is a fine crystalline long chain aliphatic hydrocarbon, and it's manufactured from natural gas, and it can be added to both binder and the mix. And smaller crystalline structure of the sasso bit to reduce the brittleness at low temperatures. And also there's a decrease in viscosity. It decreases the viscosity. It allows the working temperature to be decreased by 17 degrees centigrade to 54 degrees centigrade as per literature. And it can be added at a rate of 0.8 to 3%. And the advantages of using Sassobit are it improves the compatibility of the mixture, and it decreases the rutting potential of asphalt mixes. That's what literature says. And but it's not increases the moisture damage as other WMA technologies. So this was a methodology which we used, similar to the other one, but here, which we had discussed for the design of the wrap. But here, what we did is that for each of the, we have two samples. We have material collected from two locations. For each location, we used we conducted the test with 0.8, 2, and 3% Sassobit, and then we determined which is the best one, and then performance test was conducted on that, and the results were compared, and also it was compared with the virgin mix. Okay, so this is the design of the recycle asphalt mix containing Sassobit for sample 1, and for sample 1, as I said earlier, aged bitumen with 0.5% Sassobit, 2% and 3% was done, and BG10 was used as a recycling agent. And these were the viscosity which we obtained. And similar to the earlier case, we found out what is the ratio of the recycling agent and aged binder, and that was done for sample 1 for 3% of Sassobit, and then so this is combination of those results. And then what is the constituent in percentage? And like for 8, when Sassobit was 8%, then we varied with 8% Sassobit, we varied the bitumen content for 0.5, 5, and 5.5, and keeping the ratio constant. And we found out what is the, based on those equations which I shown earlier, we could find out what is the percentage of the virgin bitumen, what is the percentage of the wrap, and what is the percentage of the new aggregates in the recycled mix. Okay, and the same exercise was repeated for 2% Sassobit. Okay, and in this particular case of sample 1, we found that the amount of wrap that can be used in the mix is maximum when 2% Sassobit is added to the mix, and 2% of Sassobit was taken as optimum for sample 1. And so with that 2%, now we prepared the Marshall specimen, and these are the, for different bitumen content, these are the Marshall parameters with 2% Sassobit, and then we found out what is the optimum bitumen content, and optimum bitumen content was 5%, and the percentage of the wrap was 64. I told it's on the higher side, and the percentage contribution of binder from wrap was 40%, and so these are the, we just compared those values and compared it with the Morth, and you could see that the Morth specifications were satisfied, except slightly the flow value, because we got it as for 0.8, where the upper limit was 4. Otherwise, all of the values were satisfied. And then with the same exercise we repeated on sample 2 by varying the Sassobit percentage. And we found out what is the ratio of the recycling agent and aged binder, and also we found out what is for different percentages Sassobit, keeping the binder constant. We found out what the percentage of the virgin bitumen, percentage of the wrap, and percentage of the new aggregate in the recycled mix. So this was done for 0.5% binder, 5, and 5.5 with 3 different combinations of Sassobit. And so we could find that for sample 2, higher amount of wrap can be used at 2% Sassobit content, but it was found that it was not, the gradation was not satisfying the Morth specification. So so because of that, because it is falling out of the range, so because of that, the amount of wrap, but then we compared between 0.8 and 3%, and we found that the amount of wrap that can be used is higher for 0.8% Sassobit. So we decided to go with 0.8% Sassobit for sample 2. So this is what I said, like the trial and error process with 2%, since it was not satisfying the required gradation, we went with 0.8% Sassobit, and these are the Marshall values. And then we found out optimum bitumen content comes to around 5.1%, percentage of the RAP as 65.57%, and the percentage contribution the binder from the RAP is 63%. And so these are the for optimum bitumen content with 0.8% saturate, as I said earlier, it was coming as 5.1%. And those parameters was compared with the MORTH, and we could see that here also flow value is slightly, not all are satisfied, flow value is slightly outside the range, others are fine. And then what we did is that on all this, that is on the sample which we have finally, like for sample 1 with 2% saturate and sample 2 with 0.8% saturate, we conducted the various performance tests. So indirect tensile strength ratio test, static creep test, and dynamic modulus test, indirect tensile stiffness modulus, determination, red depth, etc. was done. So in the first 2 cases, Marshall specimens were casted, and the others, superpeg aerated compacted samples were prepared. And so this is about the this test setup which we use. I'm not going into those details. And this is indirect tensile strength test, condition of the sample. This is what we did in our laboratory. Excuse me. So this is indirect tensile strength test, the photograph. And this is compilation of the results. And with for the controls sample, then there's a virgin mix, sample 1. And sample 1, which is sample 1 means sample 1 here. Sample 1 means where only RAP is there, and the second case RAP with 2% saturate. So we found out what is the load at failure for unconditioned conditions, and TSR values were calculated. And the same exercise was done on sample 2 also, and TSR values were calculated. And this is indirect tensile stiffness modulus test. And so these are the values for virgin asphalt mix, sample 1 and sample 1 with 2% saturate and with 0.8% saturate. And these were the average values which were reported. And we also conducted a wheel rud test. And these are the results of that. This is at 60 degrees centigrade. Control sample, the red depth was 6.14 mm, and for sample 1 and sample 1 with 2% saturate and sample 2 with 0.8 saturate. In all the samples, we conducted this test. And TSR values also were compared for all the 5 combination, all the 5 cases. And what is the percentage increase in TSR, that was also worked out. And as a conclusion, we could say that the mix designed for recycle asphalt pavement mix and mixes containing saturate that performed through integrated mix design procedure and with Marshall test, and optimum amount of RAP and saturate content of each samples were found out. And these are the values which you obtained. Of course, I told you that is we are getting, since it's the initial work, we are getting it on a higher side. And then with addition of 2% saturate, we found that there's 1.5% and 7.5% increase in indirect tensile strength of unconditioned conditioned sample as compared to the control sample. And the recycled mixes have TSR value greater than 80%, greater than the minimum that is as per the more specification. And the TSR values of recycled asphalt mix were significantly higher compared with virgin asphalt mix. And the dynamic modulus of the recycled asphalt mix was found to be higher than virgin mix. And indirect tensile stiffness modulus of the recycled asphalt mix were higher than that of the virgin asphalt mix. With the addition of saturate to RAP mixes, there was a 19% increase in the value. In the case of mixes containing saturate, the RAP amount in a mix was higher, so that the stiffness modulus was also high as compared to the mixes containing only RAP. And regarding the red depth of the virgin mix was found to be more than the RAP mix. And addition of 2% and 8% saturate decreases the rutting potential by 8.5% and 7.27% respectively as compared to the sample containing only RAP. So, and the addition of 2% saturate have more potential of decreasing the rutting behavior. And with the addition of session, it is possible to design recycled asphalt mixes with higher amount of RAP, up to 66%. Of course, it's on the higher side. So don't take it as a final word. So which satisfies the most requirement, and addition of 2% acerbate shows better performance test results as compared to the addition of 0.8% acerbate in terms of permanent deformation, stiffness, etc. So that is all from my side, and thank you for your patient listening. Thank you.
Now the floor is open for queries. Participants can unmute and ask the queries or can post the queries in the chat box.
Excuse me.
Participants are requested to raise the queries.
If you need any clarification, you can write to me, because I told you this is more of a historical importance, I should say, because it is an work which is done a few years back. So just to tell you what kind of facilities are available in the institute and what kind of work we have done so far in this particular topic, I made that presentation. Of course, maybe to know more about the equipments and all, probably. Hello, sir.
Hello, ma'am.
I just finished and
Yeah, I know. I have been listening.
You were
I joined.
listening. Oh my God!
Yeah.
Oh, that's.
I have been there. I have been there. Yeah.
Okay. Tushara was saying that you'll be joining at 9. So you are.
No. I went. I came.
Okay. So anything you'd like to add regarding using Sasabit and all in RAP? Your comments on that?
Yeah, definitely. I will see for the benefit of most of the participants here who might be in college or students or research scholars. There has been a significant work that has been carried out related to the use of warm mix additive in RAP. So there are many reasons to that. When you add, let's say, around 30 or 40, depending on the workability becomes considerably difficult, and in fact, my voice is breaking. One second.
Now it is fine.
Okay, so maybe I think the bandwidth is a problem. Can I cut the video off, or maybe
no problem.
I will just.
Now it is fine.
Now it is fine. Okay. So just a minute. I will try to sit near the Wi-Fi. Okay. So is this clear now?
Yes, sir.
Okay. Right. So just to continue, when around 20 to 30% of the RAP is added in hot mix, the workability becomes considerably difficult. So in those days, when people started using RAP, some few years later, when
Sir, voice is breaking. Switch off video.
Okay, so let me just switch off the video. Okay, so is this clear now? Can you hear me? Huh?
Yes, sir.
Yeah.
Yes, sir.
So is this clear now?
Yes, sir. It's
Okay,
clear.
right. Yeah. So these warm mix additives started being used, and again there are many families of warm mix additives. Each additive works in a completely different way. In fact, what ma'am explained now is a bit will is to reduce the viscosity of the binder in the mixing and compaction regime. But there is one small issue with the Saxopit. What will really happen around 80 or 90 degrees centigrade as the temperature comes down, it starts crystallizing and it tries to give some additional drug resistance because it makes the binder stiffer at 60 degrees centigrade. And then if you go all the way down to 20 degrees centigrade, what can happen is the material's fatigue failure also becomes a critical issue. So now the question is, you would really want to know is, so already adding the wrap is going to create some issue in the fatigue. Why would we want to really add an additive like Saxopit? Now there are a few answers to this. Whatever laboratory work that we do on the warm mix additive seems to be counterintuitive when these things are checked in the field investigation. What happens is these warm mix additives actually give enhanced aggregate packing in the field. And this packing is which is happening below the rollers cannot necessarily be duplicated in the laboratory. So most of the time, our laboratory predictions, performance models that we develop seems to be not aligned with what we see there. So there are many stretches in which Saxopit added mixtures showed completely opposite fatigue trend, but when compared to it. So this I would say, like, which is Tushara's pet thing, which is about particle packing. Now coming back to whatever ma'am mentioned here, which is about the use of Saxopit in wrap, it's quite what I would say, like, appreciable, because she probably did this 8-10 years back, wherein the usage of wrap was not even known, and the fact that you could use a warm mix additive so that you could enhance the workability is also not that much known. Ideally, this work should have been published. I am not really sure whether ma'am published it or not. I don't know whether he published it.
No, so actually, it was at that time I was expecting my child, so I couldn't work more on it. That was a fact.
Yeah. So I really think there are considerable scope towards this kind of a work, especially when now we have a better understanding of Saxopit, better understanding of wrap, and also some refined gadgets for measuring the mechanical properties of the mixture as well as analyzing them. I mean, ideally, what I would like to do, like, and if there are some students here and they could kind of pursue it, and whatever help that is needed can be extended by ma'am, Tushara, and me from IIT Madras, is what exactly is the optimal dosage of wrap vis-a-vis a WMA additive. And the interesting point here is some of the additives which Dr. Ashish mentioned yesterday. So they come from a completely different family of additive, wherein they reduce the interfacial friction. So they are not really viscosity reducing additives. And so it will be nice if we could work on two different families of warm mix additive on the different dosages, and just try to look at simple characterization of a laboratory rutting behavior and as well as laboratory fatigue behavior, and try to do some nice optimization analysis to mention to find out how it goes. But one thing a practitioner would kind of hesitate is anything that you are going to add here is going to increase the cost. So if you add warm mix, any of these additives, they are not going to come free. There is going to be a cost. So as of now in India, there is not much awareness associated with when you reduce the temperature, what could be the potential benefits? And so that is not really well studied. So there is a hesitation in the country about using warm mix additive. But I would really say that this is considering the time period in which it was carried out, it was a very nice, interesting attempt. And I hope, some of you are here, or ma'am and Tushara, they are able to kind of refine it and take it forward to the next level. And I think that should be enough. So if there is anything else that you want me to add, I can add.
Thank you, sir, for that motivation. That was really good. From an expert like you, getting such a motivation is really good.
All of us, when it comes to asphalt concrete, is only a student, ma'am.
Okay, it's him. You are really like humble. Like we are humble.
No. This material, we all have to be humble in front of this material. Only then you can understand what this material is trying to do. And in fact, why I am saying is, if you keep varying the dosages of the SASO bit, the wrap as well as the existing bitumen, the interaction can be so interesting that you will probably be able to identify an optimal WMA additive that could give you the expected performance. So this has to be probed at multiple scales. And in fact, one of my former students, Dr. Nivita, she gave a talk a couple of days back. So she worked extensively using FTIR. So I would really try to see whether, take old wrap binder and then existing bitumen, and then try and add SASO and try and study whether, there are some new compounds are being formed, that kind of analysis. It will really be helpful. This is a very new field, and anything that we do here is adding to the knowledge that is actually non-existent as far as our country is concerned.
Okay, thank you, sir.
Tushara, would you like me to add something more?
So the kind of work that we are doing with the rejuvenators, the statistical framework and all can be also be extended to this kind of additives.
Precisely.
The interactions related to material. That can
exactly.
be one way of looking at this.
Yeah. So since the complexity here is tremendous, and since we really cannot write what you can say, a mechanistic based or rheological based analytical expressions, the only possible rigorous way in which we can do such things is through some kind of a statistical modeling, which is what I think you have done already. So so many of such attempts are there in which we just try to probe and develop some factual relationship between all these things and see what can really happen. So that is something that we should be able to do. The participants seems to be all at some low energy level, I believe.
Today is the 5th day, so it seems like a little bit energy is down.
No, I can understand. I think students from IIT Madras are also here, right?
Yes.
Yeah, I can see that.
Our first speaker, Mr. Ajay Poojary, is also here.
Okay.
He's not able to switch on his video. He has given a nice presentation on the cold mix, the in-place recycling techniques. Ajay, would you like to add something?
Hi, sir.
Hi.
Yeah, so I think we have executed some of the project using this AICTE-ATAL technology in India. Just we are in the initial stage in this technology. So coming to our industry, so the customers are a little bit reluctant going like adopting this technology because it depends on the project economics as well. So it's been on a low scale right now in the industry. adaptation-based technology. But whereas if you see mill and fill, that has been widely used in India, where you mill off the existing surface and then reuse those wrap back into the system. So that is being widely used. And this, I think we have executed some 8 to 10 projects CIPR. So it's just in the initial stage, sir, CIPR. I think in Chennai also we have done some projects in NH5 Chennai Tada under guidance of Professor A.V. Raghavan. So that was our first project, and we have done. I think last project was in Rajasthan, NH62, Biawa Pali Pindwada. So we did it on ILNT. Also.
Ideas when they coming across the surface. You know, it's you not running into the space, you're playing it out to. Okay. Thanks for the back one. That's an expectation, yeah.
Sir, we have a question for session 1, and the question is from Jay from BITS Hyderabad. Sir, in CIPR, 100% wrap can be used, but in hot mix, we bound up to 30%. What are the reasons behind this?
As you know, like in mill and fill, we mill the surface and we take it back to the hot mix plant. Right now, the asphalt plants, they are not capable enough to reuse 100% back into the system. That's why we go with 30 to 40%. And the code allows 30% back in dBm. So that's why we're using just 30%. So this dosage might increase in the maybe in the next IFC guidelines. They might increase the percentage of wrap reuse in dBm.
I'd like to add regarding this. In the previous sessions, we have seen what are the issues related to adding higher amount of wrap. So you may also refer to the presentations related to that to get the answer on to why it is not happening.
Participants are requested to raise the queries. Before concluding, I would like to notify everyone about tomorrow's schedule. Both the sessions will be handled by international speakers joining from other countries. So I would like to request all the participants to use the opportunity to maximum. The session will be starting late at 8 and will be a talk on building sustainable road infrastructure using formed bitumen technology by Dr. Nivedya, San Diego Association of Government, USA. And from 9 to 10 p.m., Dr. Sharmot Stephen, Asphalt Technical Group Leader at Intuity, will be delivering a talk on international practice in the production of wrap mixtures and recycled pavements, along with case studies. So now I would like to request Mr. Wilson, scientist at National Transportation and Research Center, NATPAC, Trivandrum, to thank Dr. Ashalatha.
Good evening, all. Today in the second section, Professor Ashalatha ma'am beautifully shared the experience gained from the studies carried out in CAT. It was a nice presentation, and the information shared here are surely a value addition to the craft industry. Thank you very much, Madam and Professor Ashalatha ma'am, for sharing your experience. Also, I thank Muralishan sir for additional information and discussions carried out. Thank you all.
Thank you, Wilson. Thank you, Melissa.
Thank you.
Thank you, Ajay. Thank you, sir. Thank you, Asha ma'am, and all the dear participants for staying till now. So we'll meet for tomorrow's session at 8 p.m. Thank you. We'll wind up.
Thank you. Yeah.
Thank you.
Thank